Why don't we build railways on solid ground? Think about it for a second. We drive on smooth asphalt roads. Airplanes land on thick, reinforced concrete runways. Skyscrapers stand on deep, solid foundations. But trains? A machine weighing thousands of tons, moving at high speed, carrying people, fuel, and entire industries, runs on what looks like a loose pile of broken rocks. It looks unfinished, almost wrong, like engineers just stopped halfway and said, "Yeah, this is good enough." But here's the strange truth. If you replace those rocks with solid concrete tomorrow, the railway system wouldn't improve. It would actually start failing. Tracks would crack, rails would twist, and in extreme cases, trains could derail. So what do these simple stones know that modern engineering doesn't ignore? Welcome to Simple Things Analysis, where ordinary things hide extraordinary answers. Today, we're uncovering the hidden science behind railway stones. To understand the stones, you first have to understand the problem they solve. A train is not just heavy, it's brutally heavy. A single freight train can weigh over 10,000 tons, and all of that weight is focused onto tiny contact points where steel wheels meet steel rails. That pressure doesn't just sit still. It moves, it vibrates, it pounds the ground with every passing second. Now imagine placing that force directly onto dirt. At first, nothing happens, but as trains keep passing, the soil begins to compress, then shift, then collapse unevenly. The rails slowly sink, the alignment breaks, and eventually, the track becomes dangerous. So, engineers needed something simple, but powerful, something that could spread this massive force without becoming rigid or fragile. And that solution wasn't high-tech, it was stone. Here's something most people don't realize. Railway tracks are not firmly fixed into the ground. They actually float. Picture the system like layers. At the top, you have steel rails. Below them are sleepers, wood, steel, or concrete supports. And beneath everything, a thick bed of crushed stones. This layer is called ballast. Now, instead of the train's weight pressing down on one solid surface, it gets passed down step by step. Rail sleepers ballast ground. And here's the magic. The ballast spreads that pressure outward, like pressing your hand into sand instead of concrete. By the time the force reaches the soil, it's no longer destructive, it's manageable. But ballast doesn't just hold weight, it also absorbs movement. When a train passes, the track slightly shifts, adjusts, and settles back into place. If everything were rigid, those forces would have nowhere to go, and that's when things start to break. Now here's a detail most people overlook. These stones are not smooth, they are sharp, jagged, rough enough to hurt if you grab them. And that's exactly the point. Imagine replacing them with smooth river pebbles. What would happen? They would roll over each other, like stepping on marbles. Under the weight and vibration of a train, the entire track would start shifting sideways. But jagged stones behave differently. They interlock, their sharp edges grip into one another, forming a stable structure that resists movement. It's like millions of tiny puzzle pieces, locking themselves in place. Strong, but not rigid. Stable, but still flexible. That balance is what keeps trains safely on track. Now let's talk about something even more dangerous than weight: water. Rain might seem harmless, but for railways, it's a silent destroyer. If tracks were placed on plain soil or solid concrete, water would collect, soil would turn into mud, foundations would weaken. Over time, the track would sink or shift. But ballast solves this problem in a surprisingly simple way. Because the stones are uneven and loosely packed, they create tiny gaps between them. When it rains, water doesn't stay on top. It flows through, down, away, gone. This keeps the ground dry and stable. In engineering terms, the ballast acts like a natural drainage system, but in simple words, it's like giving the track its own built-in escape route for water. Nature is powerful. Give it enough time, and it will reclaim almost anything. Roads crack, sidewalks split, buildings wear down, and if railway tracks were left unprotected, plants would take over, weeds would grow between the rails, roots would push the sleepers out of alignment, leaves would make the tracks slippery. Eventually, the system would fail. But ballast creates a hostile environment for plant life. There's no stable soil, very little moisture stays near the surface, and sharp stones make it difficult for roots to spread. So without chemicals or constant cleaning, the rocks naturally keep vegetation away. It's a passive defense system, always working, without effort. At this point, you might still wonder, if concrete is so strong, why not just use that? Well, some modern rail systems actually do. High-speed lines in countries like Japan and France sometimes use concrete slabs. But here's the catch: concrete is rigid, and that's a problem. Steel rails expand in heat and contract in cold. If they are locked into a solid surface, they can't move naturally. The result? The rails begin to bend and twist. This creates something called a sun kink, a dangerous curve that can derail a train. Ballast avoids this by allowing tiny movements, not enough to destabilize the track, but just enough to relieve stress. It's not about being strong, it's about being adaptable. You might think once these stones are placed, the job is done. But that's not true. Being railway ballast is tough. Every passing train causes friction. Over time, the sharp edges wear down. Dust builds up, gaps get filled, and when that happens, drainage stops working. So railways use massive machines called ballast cleaners. These machines lift the track, filter out dirt and broken pieces, and return clean stones back into place. It's a continuous cycle, a system that renews itself again and again. And here's something unexpected. The word ballast didn't come from trains. It came from ships. Centuries ago, empty ships were too light to sail properly, so sailors filled them with heavy stones to stabilize them. When the ships reached port, they dumped those stones to make room for cargo. Early railway engineers saw these piles and realized something. These stones were cheap, heavy, and perfect for stability, so they used them, and the name ballast stayed. So the next time you see railway tracks, look down. Those jagged gray stones aren't random. They're doing multiple jobs at once, holding weight, absorbing vibrations, draining water, fighting nature, and adapting to change, all without moving or making a sound. That's the beauty of simple engineering. The solution isn't always more technology. Sometimes, it's just understanding how the world already works. This is Simple Things Analysis. If this made you see something ordinary in a new way, don't forget to like, subscribe, and stay curious, because the simplest things often carry the deepest stories.